All right, we are back with the second portion of the lesson for sum and difference of angles using our trig identities. In this part, we are first going to kind of close out what we were doing at the beginning. And in the first part, we had to expand the formulas with two angles that added or subtracted to give us the angle that we wanted. And in these next couple, we're going to condense the values, condense the entire formula. So for number 5, I have sine of 40 degrees cosine of 20 plus cosine of 40 multiplied by sine of 20. So that is the sum of sines formula expanded. Okay, so that means I'm going to start with sine, and then I'm going to take the two angles that are given, 40 degrees and 20 degrees, and do exactly what the operator tells me to do. It tells me to add them together. So that condenses to be sine of 40 degrees plus 20 degrees, which is sine of 60 degrees. And we know that the y value at 60 degrees is square root 3 over 2. Okay, I'm just going to follow down the line and do all the sine problems at once, and then we'll do the cosines. We'll do the evens in just a moment. So number 7, sine of 250 cosine of 130 minus cosine of 250 sine of 130. So this one is a difference of sines. Okay, so I know that because it starts with the sine function. I've got two angles being subtracted. So it'll be sine of 250 minus 130, which is sine of 120 degrees. And the y value at 120 is also equal to square root 3 over 2, as it was in the previous example. Number 9, it is again the sum of sines, and I just need to add those two radian values together. So off to the side, let's do pi over 4 plus pi over 3, and pi over 4 would be 3 pi over 12. Pi over 3 would be 4 pi over 12. So that gives us sine of those two angles, pi over 4 plus pi over 3, equaling sine of 7 pi over 12. Now, as we're thinking about this, sine of 7 pi over 12 is not a value on the unit circle. So if we have condensed and it actually didn't make it any easier for us to just go to the unit circle and get the answer, then what we should have just done is just evaluated like it was to begin with. So sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3 is 1/2, plus cosine of pi over 4 is root 2 over 2, and sine of pi over 3 is root 3 over 2. That gives us the square root of 2 over 4 plus the square root of 6 over 4, which is the square root of 2 plus the square root of 6 all over 4 as our final answer. Okay, so that one wasn't meant to trick. It was just meant for you guys to see the process and then realize, oh, hey, in this case, if I can evaluate from the beginning, maybe condensing isn't the best option. So in our next examples, we're going to be dealing with the cosine condensing. So I have cosine of 42 cosine of 12 plus sine of 42 sine of 12. So when we have cosine as the first angle in the formula, we have to do the opposite of the operator. So we're actually going to subtract these. So number 6 is a difference of cosines. So that'll be cosine of 42 degrees, the first angle, minus 12 degrees, the second angle, giving us cosine of 30 degrees. And our x coordinate at 30 degrees is the square root of 3 over 2. Now, we've gotten that answer several times, but it's not the only answer, I promise. All right, number 8, cosine of 58 cosine of 32 minus sine of 58 sine of 32. And this one is the sum of cosines. Remember, for our cosines, we have to do the opposite of what the operation sign tells us to do. So this will be cosine of 58 plus 32, giving us cosine of 90 degrees. And our x value at 90 degrees is 0. Yay! Number 10, cosine of 2 pi over 3 cosine of pi over 6 plus sine of 2 pi over 3 sine of pi over 6. Again, this one is the sum of cosines, because we got to do the opposite of what the operator. Oh, excuse me. This is the difference. My bad. Difference of cosines. Okay, there we go. Now I got it right. So in this case, we are going to write the two angles, cosine of 2 pi over 3 minus pi over 6. We can, even though we can evaluate these on the unit circle, we sure can. It's just as easy to transfer 2 pi over 3 to be 4 pi over 6, and then subtract the two angles that are in radians. So we'll get cosine of 3 pi over 6, which is cosine of pi over 2. And you guys, we just did that. That's the same thing as cosine of 90 degrees. So our answer is 0. Great job. All right, our next chunk, this takes a little bit of work because we are going back to stuff that we did in a previous unit around the unit circle, looking at Pythagorean triples and drawing triangles to help us as we go. So real quick, we're going to jot down the Pythagorean triples. We have a 3, 4, 5 ratio. We have a 5, 12, 13 ratio, a 7, 24, 25. Let's see, an 8, 15, 17. And if we really wanted to get crazy, we could also do a 9, 40, 41. Most of the time you're going to see the top three, the 3, 5, and the 7 ones being the ones that we do the most. Sometimes you'll see that 8, 15, 17 one in there. All right, so example 12. Angle U and angle V are both in quadrant 2. Okay, so I know I'm in quadrant 2 for each of those angles. Okay, so we'll make this one U, the next one V. Determine the values of sine of U plus V. Got it? If sine of U is 5 over 13 and cosine of V is negative 3 over 5. So sketching our angles, to get in quadrant 2, I have to go to the left and then up and then back to my origin. So angle U is at the origin, the right angle's on the left, and then this is going to give me sine of U to be 5 over 13. So the opposite side is 5, hypotenuse is 13. Now, because of the triples, we don't have any work to do. We just have to remember that our x's are negative in quadrant 2. So that value is going to be negative 12. Therefore, cosine of U is negative 12 over 13. We need that ratio to help us with sine of U plus V. All right, our next one is angle V. So angle V, I go to the left, I go up, I come back down. V is at the origin, right angle on the left. Cosine is the adjacent, the horizontal distance over hypotenuse. And again, because it is a triple, we already know that our y value is going to be 4. They gave us cosine of U to be negative 3 over 5. Therefore, sine of U is the opposite over hypotenuse, which is 4 over 5. That's the one that we had to find. Okay, now we have everything we need. We're just going to type or write it all out into our expanded formula. So sine of U plus V. It is sine of U multiplied by cosine of V plus cosine of U multiplied by sine of V. So sine of U was given to us, that is negative 5 over 13, and cosine of V is also given to us, that was negative 3 over 5. So we're just taking those values that we have, because they're not the ratios from the unit circle, they're ratios from the given triangles. All right, and then cosine of U we had to solve for. That is negative 12 over 13. And then times or multiplied by sine of V that we had to solve for, which was 4 over 5. Now you guys, don't simplify anything until you get to the very end of these. because we want a common denominator because we're adding or subtracting the terms. So the first two multiply to give us 15 over 65, and, oh, that should be a positive 5. Whoopsies. Goof up there. Sine of u was not negative 5 over 13, it was positive 5 over 13. There we go. So that should be a negative 15 over 65 plus a negative 48 over 65. And when we add them together, we get the ratio, the value, to be negative 63 over 65. That is sine of u plus v for that particular example. Okay, let's try another one. Number 13, angle u and angle v are both in quadrant 3, and we're determining cosine of u plus v with the given information. Alrighty, so let's go ahead and sketch our stuff in quadrant 3. So in quadrant 3, I have to go to the left and down. So I'm going to go to the left, down, and then back up. There's u, right angles over here, and they give us sine of u is negative 7 over 25. So that's another triple, the 7, 24, 25. So my y is going to be negative 7, hypotenuse is 25, and everything, not everything, sine and cosine x, y and x are both negative in quadrant 3. Therefore, cosine of the angle is also a negative value, negative 24 over 25. All right, do the same thing, same quadrant, but a different angle. So start at the origin, go to the left, down, and then back up to give me angle V. And this time they give us that cosine of V is negative 4 over 5, another Pythagorean triple. Negative 4 will be our x, our horizontal distance, 5 is hypotenuse, and we'll do negative 3 for the y value, giving us the ratio of sine of V to be negative 3 over 5. Now, plug and chug through. So cosine, remember, we got it, when we expand, we've got to do the opposite of what the sign says. So cosine of u plus v is cosine of u multiplied by cosine of v minus sine of u multiplied by sine of v. Substitute in your info. Cosine of u is negative 24 over 25 multiplied by cosine of v is negative 4 over 5 minus sine of u is negative 7 over 25 multiplied by sine of v, negative 3 over 25. Okay, and then we will again keep the denominators. Don't simplify anything yet. The first two terms multiply to give us 96 over 125 minus the back two terms multiply to give us positive 21 over 125. When we subtract, we'll get 75 over 125, and yeah, you should go ahead and reduce because we can. Why not? So cosine of u plus v, for example 13, finalizes to be 3 over 5. We have one last example, and this one might take us right around the 15 mark, so just stick with me, gang. We got it. All right, determine cosine of u minus v. Remember, we're actually going to do the opposite when we expand this formula. We're going to add the two things together. All right, given sine of u is 3/5, where pi over 2 is less than u, which is less than pi. All right, that means that we are between 90 and 180 degrees, so that is in quadrant 2. Cosine of v, a different angle, is a negative 5 over 6, where pi is less than v, which is less than 3 pi over 2. Well, that's 180 to 270 degrees, which puts us in quadrant 3. So we have different quadrants for each of these two things. All right, so first one, quadrant 2, sine of u, go to the left, go up, and then back to my origin. So 3 is the vertical, 5 is the hypotenuse, and then we determine using Pythagorean theorem, it's a triple, a 3, 4, 5, that cosine will be the negative 4 over 5. And we were already given that sine of u is 3 over 5. Okay, so our next one, This one's not a Pythagorean triple, so we'll have to do a smidge extra work for this guy. Not a problem. We're in quadrant 3. We're going to the left, down, and then back up for angle V. Cosine is the adjacent over the hypotenuse. So I have my x value. I need my y value. Okay, so sine of V is going to be something over 6. So Pythagorean theorem is going to say a squared plus b squared equals c squared, or y squared plus negative 5 squared equals 6 squared. So y squared is 25 plus 36, which will give me y squared equaling 11, or my y value is the square root of 11. Because we're in quadrant 3, that y value for sine has to be negative. Okay, now we have everything we need. It may not be gorgeous, but that's okay. We got what we need. We are starting with cosine of u multiplied by cosine of v. So cosine of u, cosine of v, plus, because it said minus, we got to do the opposite of what it's telling us. That's what the formula says. Sine of u, sine of v. All right, cosine of u is negative 4 over 5. Cosine of v is negative 5 over 6, plus sine of u is 3 over 5, plus sine of v is negative square root 11 over 6. Okay, multiply straight across. First two terms give us 20 over 30. The next two terms give us a 3 multiplied by negative square root of 11. So that'll be negative 3 square root 11 all over 30. And we can't really do anything else other than write it as one fraction, because those two terms in the numerator, 20 and the negative 3 root 11, cannot be combined. And there we go. That one was a little bit more involved, but still the same process. Make sure you guys are practicing and let me know if you have any questions.